Hello, good morning everyone. I'm Ming. I'm going to present results about the energy system that aims to make our projects become more sustainable. Our design team decided to use a combined energy system including the solar PV system, combined heat and power system, and grid to generate the electricity that can supply the given building. Solar PV system is going to use the renewable and green sources. The roof-mounted PV system will be designed here, and most of the panels are installed on top roof of the building, which can absorb the most of energy and convert it to electricity and heat. Based on the demand assumptions and the estimation about the available area for the PV system. A system size of about 70 kilowatts DC will be used here. And in order to figure out the optimal design option, we can use the system advisor model will be used and run by changing the orientation, tilt angle, space, and quality. All of this will influence the electricity production efficiency. And based on the literature review and the system model simulations, we can know the north-faced panels with a tilt angle about 30 degrees will be the best option for the solar panel system in Melbourne. As for the space, we can see if I set the space of 2 meters, which is equal to the width of the PV of the solar panel, we can see the space, the shading. There is about 30% of shading in winter, so it will decrease the efficiency in that season. So I decided to make it bigger, make the space become 2.5 meters. We can see the shading decrease, and of course the efficiency, the output efficiency will increase as well. As for the combined heat and power system, it will generate most of the electricity and heat, and also the system size cut in value will influence it. Let's see the result table. We can see about just 6% of the electricity will be generated by the solar, and which cannot satisfy the target. Target asks us to make the 20% of electricity be generated by the renewable source. But because of the limited available area, so we cannot achieve that target. And for the CHP but the electricity generated by the solar and the CHP is more than 70, and this comply with the targets. Of course, a good design is not only just to can satisfy the goals, but also need to be cost effective and create the less greenhouse gas emissions. We can see the levelized cost of electricity of the solar panel is just $0.088, which is just half of that for the CHP system. And also let's see the CPV value, which can help us to decide which system is the best. We can say when they come CHP system is just 110 kilowatts. It's the total NPV value is the lowest, and it also can satisfy the electricity demand. Last but not least, greenhouse gas emission, which is a very important factor now. According to the two figures below, we can see the solar panels. The solar panels basically just generate a little bit greenhouse gas, which can be ignored. And we assume that the CHP system use many use the gas and the coals, and it's about 500 kilowatts CO2 will be created here. And through the calculations and the research, we can know the best option is, come back here, is like that. The solar system and the CHP with solar system with a system size of 67.2 kilowatts DC, and the CHP system with a system size 110 kilowatts, and left 30% of electricity will be generated by the grid. This is my research and results. Thank you.